Hello, everybody. Welcome to our RAG Hack live streams.
RAG Hack is a free global hackathon happening from September 3rd to 16th. RAG is a technique to get a large language model to answer questions based off your data. We have more than 25 live streams teaching you how to build RAG apps with different Microsoft technologies, plus 10 cash prizes for the best RAG apps in each category. So we're super excited to have you join us for this RAG Hack. And now a word from our friends at Reactor.
Hello, everyone, and thank you for joining us for today's session. My name is Zaskia, and I'm an event coordinator for the Redmond Reactor. Before we get started, I've got a few things to go over. Could you please take a moment to read our code of conduct? We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Useful links will be shared throughout the chat. The session will be recorded and will be available available on demand within 24 to 48 hours on the Microsoft Reactor YouTube channel, which brings us to today's session. It's going to run approximately 1 hour with time for questions throughout. So I will now turn it over to our speakers.
Hello, everyone. I am Pamela. I'm a Python Cloud Advocate, and I'm also joined by Sarah.
Hey, I'm Sarah. I'm also a Python Cloud Advocate.
Cool. So Sarah will be here to help fielding questions and raising any questions that we might be missing in the chat. So we do encourage you to post lots of questions in the chat and talk about all this with each other and share your experiences in the chat and share where you're coming from and what you're going to build. So we're going to be focusing on how to build RAG in Python, and we're both from the Python Advocate team, so we love Python and figuring out how we can build apps in it. And so we are building RAG in Python. So I like to always start off with a quick review of RAG. If you already saw some of our RAG sessions today, then this is new to you, or no, this is old to you. Otherwise, this might be new to you. So, RAG is a technique that we can use with LLMs in order to get answers that are grounded in our own knowledge base. So, for example, if we get a user question and they're like asking on a car website, how fast is the Prius 5? We take that question and we use it to search some database, and we get back results, and we send back both the user question and the results to the LLM, and then we get back an answer. So that's a RAG flow. Let's see how we can do that in Python. All right, so I'm going to go over to my Python OpenAI demos repo here. And so the first thing I'm doing is I am using the OpenAI SDK. That's, lets me use it. I can use that with OpenAI models. I can also use it with some non-OpenAI models too. And the reason for that is that the OpenAI SDK was kind of the first LLM SDK that came about in Python, and their API became kind of a de facto standard. So many APIs have like OpenAI compatibility layers where you can, use the OpenAI SDK with that API, which I think is pretty cool. So I actually have all of these examples configured so that I can use it with either Azure OpenAI or with Ollama, which is a locally running model, or with a GitHub model, which is a model you can use for free if you join this GitHub Marketplace Models program, or with OpenAI.com with a key, right? So I can use this same SDK with many different OpenAI hosts. And now I have the user message. How fast is the Prius V? So what I'm going to do is use that question to search a data store. Now, for this first example, we are going to use the most naive search possible, which is that I've got this hybrid.csv. So it's just a CSV. And really, the CSV is so short that we could even probably send the whole CSV to the LLM and it would probably be able to answer just fine. But, I wanted to demonstrate with as small as an example as possible. So this is our CSV. And so then I'm doing a really basic search here where I'm, taking that user message and splitting it up into words and then, searching the rows for it and, finding any matches, right? So, I can get back a bunch of matches here. And then, and these matches will look, like lists, lists from the CSV. Then I can turn them into, something that the LLM will understand. So I turn them into a markdown table. So this is what this code does here is it turns those matches into a markdown table. So this is a step that you always have in RAG is that, you get your data sources, you need to convert it into a format that the LLM will understand. And LLMs understand many things. They understand markdown really well. They understand XML, HTML, JSON, just straight up paragraph, right? There's many formats they understand. And sometimes you just experiment and see what they understand the best. So that's what I did in this case is just turned it into a markdown table. And then is the LLM step. So I have a system message that says, okay, you answer questions about cars. You must use the data set to answer the questions. Do not provide any info that is not in the provided sources. So I send that system message and then the user question plus the sources to the LLM, right? So I'm sending it to a particular model with a temperature of 0.3, which is like between 0 and 2. So it's fairly non-creative, which is generally what you want for RAG. And then, then we got the messages and then we get the response. So here we can see the response is the Prius 5 has an acceleration of 9.51 seconds from 0 to 60 miles per hour. So there we go. So that was a answer that's based off the table. You can see here that the LLM looked at the rows and it found the row that had Prius 5 and it knew how to read that column and extract out that 9.51 value, and then it knew that it meant from 0 to 60 miles per hour. Or that's what I assume. I actually don't know anything about cars. So maybe, Sarah, do you know cars?
No, but I think that is a pretty common metric. So I would guess that part came from the rest of the LLM that wasn't trained on the specific data here from the RAG.
Yeah. So that's the interesting thing. When you do RAG, you're getting a combination of the knowledge that's in its weights, right? So in its weights, it understands generally what it does mean when we ask how fast something is, and it understands when it sees an acceleration column that generally means seconds. So the interesting thing is like the LLM actually knows more about cars than I do, right? I actually wouldn't know how to read this table, but luckily LLM can do it for me and answer the question. So that was a really, really simple RAG. Now, no, most of the time we're going to use an actual way to store our data that isn't just a CSV, and we're going to use a much better search than what I did here. So never ever do this in your actual code. That was just to demonstrate.
What? No grepping? No just using CSVs? What are we supposed to do then?
Yeah, so what we want to use a real retriever. So it could be a database, a search. I'm going to be showing Azure AI search today. That's going to be the focus of today's session, but we have sessions with Cosmos DB, with Azure SQL, with MongoDB on Cosmos. So we have a bunch of sessions. I have actually tried. I've got us also a session with Postgres tomorrow too. I did even try SQLite, but I found that the full text search in SQLite just wasn't good enough for these kind of questions that I was getting. And then SQLite doesn't actually have built-in vector support. Somebody in the community just came up with a plugin for SQLite for vector search, but it's not like part of SQLite. And your other option would just be to like kind of do in memory with Python. If your data is small enough, you could potentially do an in-memory search, but you do need to have some way of taking a question like this and being able to do a search with this question, right? So let's see what it would look like with Azure AI search. So I'm going to go to another repo. Okay, and let me go to my RAG. Okay.
And the link is shared in the chat for these. Made sure. Okay, great. Thank you. So you can get that repo from the chat. And this is rag.ipynb. It's a Jupyter notebook that steps through the steps.
So the first thing we have is that, once again, I bring in that OpenAI SDK. And then this time I'm also bringing in the Azure AI Search SDK because I'm going to connect to an existing Azure AI Search instance. So this all sets up Azure OpenAI. This sets up Azure AI Search. And then this is just a convenience function for generating embeddings. So the first thing we do is we get this user question, and this time it's what does a product manager do? So this is going to be searching on a search index that's full of documents about like kind of internal company documents, like HR documents, and hiring documents, stuff like that. So I get that user question, I turn that into a vector so that I can do both a full text search and a vector search. So I'm using OpenAI embedding model here in order to turn it into a vector. And the next step is that I would use the Azure AI Search client to search the question, search also with the vector that we just got. So we're doing both a full text search and a vector search. And we're also using the Semantic Ranker stem, which helps quite a bit with retrieval quality. And we're asking for 5 results. Top equals 5. And then when we get back the results, I join them all together just by, taking the page that they're from and then taking the content that was indexed and just, putting that in brackets with a little colon here. So what you can see as a result is we see, role library.pdf hash page equals 29. It says, oh, the manager of product management, blah, 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 right? So it found that. It also found something on page 28. So it finds all these results and then combines them all together. So this is what the sources look like when you're doing a RAG on documents. You're getting back all these chunks of documents that you indexed earlier and then, putting them all together with their page numbers. Then we're going to send them to the model. So once again, we have a system message that grounds the answers in the facts. So we say, okay, you have to answer only with the facts listed. If there isn't enough information, say you don't know. It's really important to try and get the LLM to say it doesn't know. LLMs really, really like to know. They like to be very helpful. So you really have to, make it clear to them that they should only answer if they see it in the sources. And then we describe the sources. So we say like, okay, each source has a name followed by colon. Include the source name for each fact used, use square brackets to reference the source, like info1.text. So we're describing how the sources are formatted and we're describing how we want citations. So that's another important part of the RAG system message. So then I take the user question and add on the sources. Yeah.
Someone was asking, are the top 5 results, so on technically the previous block of code, are they ranked based on the re-ranker score? Or I think you had, it was what is the ranking metric there?
Yeah, great question. And we are gonna, I don't have that slide here, but we are gonna dive really deep into this in the Thursday session on RAG with Azure AI Search. So we can talk a lot about Semantic Ranker there, and we'll actually have an Azure AI Search PM at that session. But yes, these actually do get re-ranked based off of the Semantic Ranker score. So what happens is that it's even turned it, I just sent it off. It's live, people. How do I press enter in just a normal enter? I see. Yep. Okay.
Shift enter runs it.
I kept pressing shift enter. So what will happen is that it does the full text search with the user question, then does a vector search, then merges them using this algorithm called reciprocal rank fusion. And really all that algorithm does is say this result was number 1 in the vector search. This result was number 2 in the full text search. So it's going to have, this combined rank of, 1.5, right? Something, like that. So it's basically looking at where things show up in the full text search, where the results show up in the vector search. And if they show up in both columns, then they'll get a higher rank in the merged list. So that's reciprocal rank fusion. You can even implement that yourself. I've got that implemented in SQL for the Postgres one. So that's what and then they get re-ranked using Azure AI Search Semantic Ranker. So this is a model that's been trained to do re-ranking. It has one job. Its one job is that it sees a user question, it sees a bunch of results and says, well, for that user question and those results, actually the ranking should be 3, 4, 5, 2, 1, something like that, right? And this is literally the model that's used by Bing.com when it re-ranks results for searches on Bing. So it's like quite good since it's used by Bing. And yeah, and so we can use it for our Azure AI search as well. So I find this particularly important if I'm doing a vector search, because vector search does have a tendency of like finding noisy results, like things that are, aren't actually as relevant. So I like to definitely use a semantic ranker in order to bring up the most important ones so that they're in the very top. So that's what this does. We're going to go deep into it in the Azure AI search session, and you can ask more questions there. But this is generally a really good approach. And Azure AI search does it for us. If you are using, any other retriever, then you definitely want to look into being able to do a similarly powerful search, right? Because you want to get a small number of results and have them, ranked so that the most relevant results are in there and that anything irrelevant is dropped out. We could also be like dropping out we could set a threshold and say, hey, drop any results that have a semantic ranker score that's too low. That's the other thing, is that, vector search will always find results. That's the danger of vector search. Will always find results, even if nothing is relevant at all. So you want to have some sort of scoring mechanisms to like drop something that just seems completely irrelevant.
It's like my dog when it doesn't really realize what is, I'm asking for the ball, but anything could be a ball, really. It's going to bring me something.
Yeah. So you want a way to drop it. We really want to get only the relevant stuff, because generally, like LLMs, garbage in, garbage out. If you send LLM great results, you will get great answers. If you send LLM noisy results, distracting results, well, the LLMs can be led astray, right? So we really want to get really nice results there.
The link to the session that Pamela's been talking about is in chat coming up. So if you want to learn more about the rankers, check it out.
Thank you. Good question. All right. So we send that, and we get back the response here. So a product manager is responsible for leading the product management team. And then at the end, we see the citation. And good. So this is a good answer. It's grounded in the response and it has a citation. That is what we're looking for a high quality RAG answer, is that it is grounded and it has citations that are in the format that we requested, because then we can pull these out with our application and make them, clickable links. All right. So now we've seen that basic example. Now we're going to do do a deep dive. All right. And we're going to do a deep dive into the Azure Search OpenAI demo. And I did see a mention of it in the chat. So that's what we are going to dive deep into. This is a fairly sophisticated code base. It has a lot of features in it because it is our most popular RAG sample. So we get a lot of community PRs to it. Like I merged one last week that added internationalization, which is really, really cool. So I actually set it, to me, it defaults to Spanish now because I said it, but I set it back to English for this session. So it's back in English now. But it's got a ton of optional features, which is great for all the developers that are working with it, because you can basically just enable the features that you want and it'll bring them in. But if you're hacking, you might find it a bit much overwhelming, right? So you don't have to start with such a complete solution, especially if what you're going to do is really different. But if what you're going to do is really similar to what this repo does, then it is a really nice starting point. And I like to show it because it does have so many features in it. And because it is fairly battle tested as well, because we've had thousands of developers deploying it. So you can get the code for this one at aka.ms/ragchat. And you can even try it out at aka.ms/ragchat-demo. This link should currently work. Yeah, it looks like it's loading now. So I've also got it running locally, but you can try it out yourself to see what kind of features it has. And I think this one is even the one that has vision enabled. So you can even try that vision feature that I was talking about. So you can play around with it here. So, and here you can see the question that we were that we were just going through. So we're going to dig deeper into things using this example repo. Now for the application architecture, we have the user here. The user asks a question that goes to either Azure App Service for the deployed one, or your local server if you're running locally. And then the RAG flow uses a combination of Azure AI Search and Azure OpenAI to answer the question. Then when the user clicks the citation, that sends another request to either App Service or your local app server. And that uses the Azure Blob SDK in order to fetch the citation from storage, checks to see if you are allowed to see that citation, because one of the optional features is user authentication with data access control. So if you have that enabled, then it'll make sure that you actually do have the option to see that citation, and then bring it back and render it in the UI. So that's what happens here. So, I'll go ahead and, I'll do it on the deployed one here so we can see it working. All right, that came in pretty fast. And you also see that the response streams in. So that's another best practice, is to implement streaming, because that's going to reduce the perceived latency for your users, because they'll start seeing the response as soon as the first token is available. You can start sending in that response. So you definitely want to have streaming as an option, and most developers just default it on here. We've got all of these settings here where you can play around with stuff and turn stuff on and off as you're developing and decide what you want to use in production. I also saw there was the question about the language picker. If I had Spanish configured as my default language in the browser, it would be Spanish. I just cleared my cookies for that. Or you can also optionally enable a language picker. So if you go to the repo, we have a bunch of docs in here, and you can go to the deploy features doc, and that's where you can see all of our optional features, right? And basically you just set some parameters, some AZD deployment parameters before you deploy, and it'll just set everything up for you, right? So for the language picker, you say, oh, AZMSet enable language picker true. And then when to set it all up, you'll see a language picker show up in the UI once it's deployed. So we've got lots of features here. There's the vision, and I'll talk about that in my vision session. There's using different GPT models, using different embedding models, using speech input output, using authentication, data access control, user document upload, and using private endpoints, using alternative parsing mechanisms for PDF files. So bunch of options here. As I was saying, we've worked a lot on this repo. We've had lots of great community contributions, and we've seen all the things that developers want to be able to do. All right. So let's look at this simple RAG flow. All right. So we implement both simple RAG flow and advanced RAG flow. So I like to distinguish between them. So if we look at the Ask tab here, and I'll go to my local one here. So here's the Ask tab. This is what I would call a simple RAG flow. So let me go ahead and go in here. Well, let's do it in the diagram first. Okay, so we have a question, right? And we take that question, we use it to search Azure AI Search. We get back responses. We send the question and the response to the LLM, and we get back an answer. Okay, so let me show it in here in the deployed version. Okay, and then what I can do is click on the thought process. And in the thought process, we can actually see what happened, right? So we got the user query. We used that to search the AI search index, and we got back all these responses. And this is really the same thing I showed in the notebook. And then we sent that to the LLM, and we got responses from the LLM. So this is what we call a simple RAG flow. And it's basically what I showed in that notebook. But let me go ahead and walk through the Python for it too. All right. So what I've done is I'm using the VS Code debugger in order to be able to step through the code. Let me make my code bigger here. Big, 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 big. Okay. All right. So I've sent that same request off in the local host, and now I can step through the code for it. And, you know, basically the first thing that happens is we check to see what all of our settings are, right? So we've got a lot of settings here, like what's the user question? Are we using a seed? What kind of search are we using? I see a question like, is Azure AI Search like VectorDB? Yeah, so Azure AI Search is you know, both can do a vector search and can do a full text search, right? So this is a big point I want to make, is that you often need to have both vector search and full text search. If you only have vector search, you are going to miss out on being able to answer some queries. Like if somebody had a you know, was searching for an exact name or email or phone number or something like that, then vector search isn't going to work as well. So we're using Azure AI Search so that we can do both a vector search and a full text search, right? So we typically default to doing both text and vector, and we can see that here. It says use text search true and use vector search true. Let's see. We have some more search settings. How many results we're going to get. We default to 3. Whether we're doing a score threshold, and we default to not. Whether we're doing any sort of authentication. This one, we're not doing authentication checking. Then we build we turn the user query into a vector so that we can do a vector search. And then we pass all of that stuff to our AI search SDK call. So this behind the scenes is calling to AI search using the same kind of code I showed before. And go through. All right, so it's getting back the results from AI search here. And sending it off. And let's see, I think it's just still pending here. I knew this would happen. All right. Yeah, this always happens, is that in the middle of the thing, it always wants me to re-log in. That's why I went and grabbed my phone. Okay. All right. I'm just going to re-log into my account because my credential expired while I was demonstrating it. Okay. All right. So that should be okay. All right. I'll go and do it again. All right, so that's starting up again. I also see there's a lot of questions. So Sarah, is there a question? There's so many.
Yeah, sorry, I was actually responding to some of them in chat while you were working on some stuff. Folks were asking about the potential latency issues of having both the vector and the I guess regular.
Oh, and keyword search. Yeah, vector and full text search. Yeah, that's a good question. I mean, you could look at the latency. So here's the thing. My thing with latency is that the LLM step is always by far the slowest, at least with Azure AI Search, right? I have done performance profiling on this. And yeah, the AI search step does take some amount of time, but the LLM step is generally a lot slower. So that's tend to be where I, spend my kind of like performance time. But yeah, you could certainly, you can evaluate the latency and see whether increased latency is worth it. AI search is fairly optimized. We are using a index with the vector search. We're using HNSW, which is a approximate nearest neighbor search algorithm, which does make vector search a lot faster. So you definitely don't want to do like a brute force vector search for a user facing application. You want to use a heuristic search, right? So I find that the latency is fine for doing both, at least with Azure AI Search. They're fairly optimized for performance, but that is a great thing to look at when you're evaluating answer quality. Is is it worth it to do combined hybrid search? And also the re-ranking step does also add latency as well. So it's just something that you need to evaluate for yourself, right? And it's going to depend on on your data cert. But when I've run evaluations, I have a blog post here. Vector search is not enough. I'll share that so we can post in the chat. But you can see here when I ran my evaluations and I looked at vector, text, hybrid, and hybrid ranker. And I actually do have the latency numbers for this. I didn't put it in this column because that wasn't the point of the blog post, but I did measure latency as well. And, and so that's something you could look at in combination. But generally, the results were just much better for me when I used hybrid with Ranker, and I didn't see a big latency change. So that's why I went for it. But it's something that you can evaluate and decide for yourself whether, whether it's worth it for your use case and your data, and whether you can get good enough quality with, just doing vector or just doing full text. Some people only do full text. Some people only do vector, right? It just depends what works for you.
It probably comes a lot back to the whole garbage in, garbage out that you were talking about earlier. Like maybe, perf is always gotta go fast, but if you really want actually good results from it and not to be like, why am I wasting my time with this stack? It's probably worth the extra latency to do more.
Yeah, for sure. If what you're noticing is that you have poor quality answers and it's because of the search step, then then you just need to find a way to improve those answers, and it might mean that it increases your latency. So such is life. All right, so we're back to this. So I do the search, and then I get back the search results. So then I concatenate them into something that I can send to the LLM. So you can see here, like the user content is going to be, it's kind of hard to show stuff in the debugger. This is why people use notebooks. But here you can see the user content. What does the product manager do? Sources, blah, 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 blah. All right. And then the next thing I do is that I actually figure out how much I can send to the LLM, and kind of, if I had any conversation history. Now, in this case, I don't have conversation history, but I do have some few shot examples. So this will just figure out whether I can send everything to the LLM that I want to send it to, or whether it'll go over the token limit of the LLM for input. And so I get back what I can send, and then I send it to the LLM. All right. So here I'm defaulting to 0.3 temperature. I tell it to stick to a reasonable size, which is like 1024 tokens. And then I get back the response. So that is our basic ask approach. And then that'll get back this response here. But most of the times people want this advanced RAG flow here. So let me click on the same question here. And actually, let me just play through it the first time. I said a bunch of breakpoints. Okay. All right. So here's our advanced RAG flow. And we can look at the thought process here. And in this thought process, the first thing we do is the query rewriting step. And this is using function calling in order to say, hey, here is the user's question. Please turn this into a good search query. So then it turns into a search query. And in this case, it actually didn't do any transformation. But in other cases, it will do transformation. So I'll show another example where it will. Then we get back the search results, and then we send it to the LLM. So the big difference here is just this query rewriting step. So let's say I asked what else, right? Okay, and then we get, let me go through all the breakpoints. Okay. All right. And now when I'm going to look at the thought process, what we see is that the query, that didn't work very well, actually. That's interesting. Which model? I'm using GB35 Turbo. Okay. So that's interesting. I said, what else? Most of the times it'll actually turn this into a better query. So I expected it to turn this into product manager responsibilities. That's usually what it does. This time it didn't. LLMs can be a little finicky like that. Let's try it over here too with this one. Let's see. Maybe I'll be a little more precise, right? Okay. Okay. And what else do they do? All right. Let's see. Okay. And this is answering correctly. Okay. And so if we look at the thought process here, yeah, this time the query rewriting step turned it into product manager responsibilities, right? So this is one of the goals of the query rewriting step, is that especially when you have multi-turn conversations, like these back, where you're asking additional questions, that query writing step can fill in missing context. So let me try that again. It still answered the question fine. It just didn't need those additional results. But let me say, okay, and what else do they do? And I'll just show you the code for that function calling. All right, so here, okay, so this is our function calling definition. When you're using function calling with OpenAI, you define your function. You're using basically defining the specification of the function. We're saying, hey, we have a function named search sources, and it takes a single parameter, which is a search query, and this is what that search query is. And then it's going to come back with its suggestion of what the function call should be. So it is a way of getting structured outputs. There's a new way to get structured outputs that's literally called structured outputs, but it's not yet fully supported by Azure OpenAI. So I haven't ported to that yet. But generally, it's a nice thing to be able to use function calling or structured outputs in order to be able to get more structured responses from an LLM. And you can build on this query writing step to do more things. Like you can have an additional function that will search from a whole different source, right? And so you can use the LLM to like decide whether it's going to search AI search or whether it's going to, search a GitHub tracker or something, right? So there's a lot of stuff you can do once you have this query writing step, because you can throw in different functions, throw in different parameters, and have the LLM decide based off the user query what it thinks the next step is to do. So it basically becomes, this is like your path to agentic RAG, is function calling and having this first step, which can serve as a planning step and a decision step. So we define that function, and then we send that, to the LLM, and tell it that it's going to use that in order to come up with the search query, and then we extract it out of the result, and then the rest of it is the same, right? It's just the addition of that step.
If you've got time, one more quick question. Yeah. Someone was asking about, so you were talking about it kind of rewriting your question, saying what else, actually turning that into a sensible question. Does it add anything else or add any other context as a part of that? Or is it just basically rewriting the question?
Yeah, great question. So what you can see here is that we have the system prompt that says, okay, here's the conversation so far. Here's the new question. You have access to a search index, generate a search query. This is, the kind of punctuation requirements. Here's the translation requirements, right? We have it to translate to English because our document set is in English, but you would, obviously change that if your document set was not in English. And then we have actually a few things. We have, here we have few shot examples. So we actually start with the few shot examples, which are a few shot examples, just an example that we've added to kind of show how we expect it to respond. And what you can see here is that then we add the actual conversation history, right? So the user asks, what does a product manager do? And we have the answer here. So it does have the context of the questions that have happened before. So we can look at all of this and then decide how it's going to rewrite. Now, it's a little weird because in this, we haven't done this perfectly. There's actually a PR that improves upon this, and it's on my list to review. It's from last year, but I want to do like a full evaluation of it. And this was from somebody who has a different approach to how they're doing the history, which they say has worked better in their evaluation. So I do want to potentially merge in this PR, because right now we kind of have both like conversation history, and we have examples of taking a user's question and turning it into a query. So we're somewhat mixing the formats here, which is a little odd. And that's what this PR does, is that it improves the query generation. So I don't actually think we are doing a perfect query rewriting step here. And I hope we can keep improving in the future. It does actually do pretty well, even though it's not perfect. Yeah, I just want to acknowledge that there is definitely improvement there. And a great thing to do is always just check the PRs for our repos and see what other people have suggested. And you can see more examples, right? You can also see I have a PR that shows how to use tools to do more specialized queries. Like I think I said something about, right? You could use tools for doing summarization. So yeah, some work to do there. Yeah, I think there's a lot of ways you could improve this. So yeah, if any of you do work on this repo and make any improvements, please do share what you do in a PR or a branch. Even if we don't merge it, or even if it takes me a year to merge it, which sometimes happens, I still think it's really valuable because people will just look through the PRs and just kind of pick and choose what is helpful for them. Because it's very hard to make a generic RAG app that like works for every possible, use case and scenario out there. And that's what we're attempting to do. But it's hard to do for everything. So I love when people share their PRs and their branches, even if we don't, merge them or we take a long time to merge them. I still love when people share them, because if it's been useful for you, it's probably going to be helpful for somebody else as well. I also see the question is, do we need to connect to a database to store the conversation history, or is it handled in memory? Yeah, so that's a good question. So in the current version of the repo, everything is in the front end, like in the front end memory, right? So everything that gets passed actually gets passed because the actual JavaScript is remembering what's there. That does mean if I reload the page, boom, it's gone. Okay. So, you can have a long conversation here. I gotta press play there. But this will all be in memory. Now, talking about PRs again, the oldest PR in our repo is about adding conversation history, and this is adding it using Cosmos DB. This one is kind of out of date, but there's somebody who has a more recent branch that is actually mergeable with main. So if you're interested in conversation history, I can point you at the most recent branch that that implements it. So that would store it in Cosmos DB. It seems like everybody's just using Cosmos DB NoSQL for storing it. I think because it works pretty well because you just associate it with like the user ID. And we do now have user login for this app. So I think it's now really makes sense to have conversation history, because you could log in, you could tie it to the user's Entra ID and then store it that way. But right now it's just stored in the front end. The front end sends it to the back end. And then we have the step that figures out how much conversation can fit inside the context window, and then sends as much of the previous conversation as fits, and gets back the response. All right. Anything else before we move on?
Don't think so.
All right. So we saw the advanced RAG flow, which had the query rewriting step. We talked about Azure AI Search and mentioned that we do have the session where we're gonna dive into the how the search works. So if you have more questions about AI Search, do come to that session. And this slide just gives an overall architecture of the code. So it has a front end, which is written in TypeScript using React with Fluent UI components. And so generally you'll find things in chat.tsx for the chat flow, or ask.tss for the ask flow. And, and they'll make calls to the backend. And then the backend is in Python, obviously. And it is a Quart application that we run with Uvicorn and GUnicorn in App Service. There is a main file, which is app.py. And that's kind of your starting point for everything. And you can see this has, handlers for the different requests. So we've got a handler for when you make a chat request. We have a different handler for when you do a chat stream request. Even though it is pretty similar, it's also a little bit different. So we do have separate handlers for the streaming responses than the non-streaming responses, just because they do give back a completely different type of HTTP response. And then the same thing for ask. There's a /ask and then a /ask. Well, actually, an ask doesn't even do streaming. So there's just a /ask. So the main endpoints are /ask, /chat, and /stream. And then there's a few other endpoints for like rendering the citations and some configuration and stuff like that. So these will go through to, files in here. So, we've got like a file that's for the chat tab. And, this has the code that we walked through that does the whole RAG flow. And so you can, anything you want to modify, you can modify in these files. You can change the system message. You can change steps. You can change the function call that happens here. You can modify all of it here. So we've got a separate file for chat with vision, ask, and ask with vision, depending on, what it is you're trying to modify. And then they each go through the steps. So that's the general architecture of the code. It can be a little intimidating because there's a lot going on in it. So I think it helps to, see roughly where things happen and, what you can change. And you said that I was using the VS Code debugger to step through it. That's something you can do to try and help understand, what is actually happening at each step of the RAG. Now, I want to talk about the data ingestion process too, right? So we stepped through all the code for it actually happening live. But before we were able to do all this, we had to ingest the code. And so that's with all this code that's inside the backend prep.docslib folder. And I'll go ahead and just run it here. So let me basically add a new PDF here. All right. And then I'm going to go ahead and run prep docs. And so this script runs automatically when you're doing a deployment, but we can also run it manually when we have a new document. So first it's setting up a Python virtual environment and installing all the requirements that it needs. Then it's checking to see what files it needs to process. And so it sees, okay, it's already done a lot of them, but it sees that it does need to process benefitoptions.pdf. The first thing it does is extracts text using Azure Document Intelligence. So Azure Document Intelligence is a service from Azure that's very good at extracting text from lots of different formats. So PDF, DocX, PPDX, XLX, all of these different formats, even images. It can extract text from images, only text from images. If, it's not going to extract text from a photo of your dog, but it will extract any text it finds in images. So it can extract all sorts of text from all sorts of documents. The next thing we do is we take that text and we chunk it into sections. And so we turn each of those sections in, we turn each page into like a section that's like 500 tokens big so that will be a nice size for the LLM. Then we upload the blob for the whole file to blob storage so that we can use it for our citation. And there's some additional things actually, because this is the RAG with vision one. So it's also doing some image embedding and some image uploading here so that I can do RAG with vision on it. So I'll talk about that in the vision section. And then finally, it computes embeddings and stores everything in Azure AI Search. So that is the data ingestion. And so we use Azure services where it makes sense. But if you want to, you can also, instead of using document intelligence, you could use a local PDF parser. You could use a local HTML parser, right? If you have other ways of extracting text, like when I did a RAG on my blog, I just used Python Beautiful Soup with the HTML and extracted the text just using Python Beautiful Soup. So Azure Document Intelligence is generally a really great tool for general purpose document extraction, but you could also bring in other parsers depending on, what data form you're in. And so all of the code for prep docs is inside the prep docs lib folder. And, so it's all inside here. There's a main file as well, which is prepdocs.py, which calls everything in the folder. Your other option also is if you're doing RAG with Python, you don't have to invent everything yourself. You don't even have to use this stuff. You could use something like Llama Index or LangChain because they have a lot of data ingestion code as well. So the point is you need some way of doing this data ingestion if you're going to do a RAG on documents, because you need a way of extracting the text from the documents and chunking that text up, right? So this was the flow that I just showed, right? Uploading to blob storage, extracting with Azure Document Intelligence, splitting data into chunks, vectorizing using Azure OpenAI embedding models, and then storing in Azure AI Search. So that's what PrepDocs does. But you could, do something similar using Llama Index or LangChain if you, want to try using their their ingesters as well. You're just looking to have a process that is something like this.
If you have frequently updating docs, or if you say, do you have to, my guess is you probably have to rechunk it, yeah?
Yeah, great question. How to update a document that has been chunked, right? So for this particular repo, we have the ability to remove files from the index. So it's with this remove command, and you could just remove it and then re-update it. But if you're developing like a production app, then you're going to want to have a better, workflow for that. So one option is that you could use if you're going to use Azure AI Search, they also have built-in indexers and skills that can connect to two common storages like Azure Blob Storage. And so they could actually keep track for you when something's been updated, and then they would do it for you. So there's this feature called integrated vectorization that's designed for RAG for AI search that you could connect up to an Azure Blob Storage. So that would take care of it for you. Or you could use like an Azure function and, get triggers from wherever you're storing it. So it's definitely something good to keep in mind. Is that you're going to want to, basically remove the existing chunks and then update them. So that means you need a unique way of identifying them. So making sure that you have a field in your search index or your database table or whatever that indicates where it came from, so that you could remove those and update them when necessary. And does PrepDocs create a new index or update an existing one? So PrepDocs will create a new index if one doesn't exist, and otherwise it'll update an existing one. So generally, you can, if you're using this repo, you can go ahead and check how you can deploy using existing Azure resources, right? So if you have an existing AI search resource, you could use existing ones. So generally, you can always use existing stuff if needed. But when you're making an index, the index does need to be consistent with the rest of the app, right? So the app assumes that the index has certain fields, right? It assumes that the embedding field is named a certain way and that the citation field is named a certain way. So, if you're going to be using it with an index that already exists, you would need to modify all the code to make sure it's compatible, right? That you're, searching the appropriate things, getting the right metadata from the appropriate places. So that's why it can be hard to just bring a search index that you made before, because it may not be RAG compatible, or it just may take some work to make it RAG compatible, right? Or, at least compatible with this application. Okay, so if you did want to get started with Azure Search OpenAI demo, the general approach is get the code, deploy the app, add your data, deploy locally, and do customization. So for opening the project, you can open in GitHub Codespaces, which is open a little VS Code in your browser. You can do VS Code with dev containers, or you could just do a local environment as long as you've got Python, Node, and the AZD CLI. Then you do need to have, for this one, you do need to have a Azure account and subscription. You could use a free account if you have that, but it will have some limitations. Then you'll need access to Azure OpenAI, which everyone should have now. We recently changed it so that you don't have to fill out a form. So you should all be able to access Azure OpenAI now. And then you also need some Azure account permissions, which you should have on personal accounts, but these might be hard on corporate accounts sometimes. It depends on your corporation and how they've sent their permissions. Then you can use the AZD CLI to deploy it, right? So you log in, and you actually saw me. I had to log in earlier today during the stream. Create a new AZD environment, which will keep track of all your deployment parameters. And because if you do any customization, like enabling optional features, it would be associated with this, deployment, this environment. And then you run AZD up, and that will provision all the resources and deploy the application code. So I did AZD up earlier today. So let me find my AZD terminal here. Okay, so I'll just go scroll up so you can see. Okay, so AZD up here, right? So you can see the first thing it does is just package up the application code. Then it provisions all the resources, right? So we can see that we made AI, we made AI search, we made app service, we made document intelligence. So we've got all those set up. Then it runs that PrepDoc script, and we saw what the PrepDoc script does. So it checks to see if anything else needs to be ingested. And then it takes the application code and it sends it to app service and gets it up and running on app service. So that whole process, that time took about 30 minutes. So, it takes a little bit of time because there's a lot happening here. But the cool thing is at the end is that you have this, fully working RAG application. And, when you're hacking, you don't want to spend a lot of money. So we have instructions for how you can deploy for free at aka.ms/ragchat/free. So I recommend checking these out if you're trying to minimize your costs, if you're doing experiments, prototyping, or hacking for RagHack. So basically, this shows you how you can use the free tier of app service, how you can use the free tier of Azure AI search, the free tier of Azure Document Intelligence, but that will only let you do 2 pages of each PDF. So in that case, you might want to just use the local PDF parser or local HTML parser, depending on, what it is you're parsing. You could turn off Azure Monitor, even though that's really, really cheap. And then you could even point at OpenAI, but I think the costs are actually the same between Azure and OpenAI.com, but that's just an option you can have. You could disable vector search since that does add a little bit of costs. And then finally, you would run AZD up. So this is, a way you can reduce costs locally, reduce costs in production so that you don't, so you're using the freest tiers possible. All right, and then you could add your own data. So we can run that prep.op script like we saw. You can run the local server using these commands here, and you can get hot reloading if you want hot reloading. Then you can customize the front end, and here's some quick tips to where you can find common things that people customize. You can customize the back end, and I kind of walked around there and it showed the system prompts. And customizing the prompt is really common because it has a lot of stuff specific to the domain. So there you'd want to change it. Okay. All right. So that was a deep dive into that demo. Oh, and now I realize I'm going long. Okay. Sorry.
Lots of good questions.
So long. Yeah. Okay. All right. So just briefly about choosing a Python web framework. Okay. Because this is something you'll have to decide when you're making a RAG hack. So here's the thing: is that many frameworks are synchronous. A synchronous framework can only handle 1 request per worker. The problem there is that request to like when we get in a request from a user and we send off a request to LLM, that takes a really long time to respond, right? That can take like 5 seconds, whatever. That's a long time. During that time, that worker cannot do anything else at all. It is blocked while it's waiting for the LLM response. So that means the worker can only handle 1 user request at a time. If we use an asynchronous framework, then what can happen is that the worker, gets a chat request, they go make the LLM request. While they're waiting for the response from the LLM, they can go handle a new request and start doing processing for that new request, and then send off the request for that one. So it's a way that we can handle new requests while we're waiting on I/O. So it's particularly important when you're working with LLMs because LLMs can be so slow. So when you're choosing a framework, that means you shouldn't be using Flask because Flask is a synchronous framework. Instead, you should consider using Quart, FastAPI, Starlet, or Django with async. And I have a blog post that goes more into Quart versus FastAPI because that's maybe what a lot of people are deciding between, but generally all my samples are either Quart or FastAPI, and they'll both work well. But the point is use something that's async, and then make sure that you're also using the async APIs for any of your blocking calls, right? So you want to then use async with OpenAI, and that means using the async OpenAI constructor. You also want to use async with Azure Python SDKs like Azure AI Search. And so you'll want to look at each of those SDKs that you're using to figure out how can you use the async version of the calls. And that way you can get much better performance. So this really matters, especially when you're going to make a production ready RAG, because then you can actually handle a lot more user requests with lower amounts of resources. Okay, so let's talk about other RAG and Python solutions. 1 minute left. What's in a RAG, right? We often want to do vector search embedding models, right? So we've got different models that we can use and different SDKs we can use with it. So I showed with OpenAI SDK, there's also the new Azure AI Inference SDK that you could use. And we are going to have a session from Facundo on that next week that you should check out. For retrieval, if we're going to use Azure stuff, we're usually going to use the Azure Python SDK. But if we're using something like a database like Postgres, then maybe we're going to use like SQL Alchemy. So I'll show that in tomorrow's Postgres session or Thursday's Postgres session. And then for generation, when we want to model, so we can use OpenAI or Azure AI inference, right? So those are generally the SDKs, packages that you're going to be using. There are lots of orchestrators, and I did see a question about this, like, can you use an orchestrator? You can definitely use an orchestrator. So there's tons of orchestrators out there that will make it easier to chain these calls together. I don't personally, really use them in mine. I tend to only use OpenAI, but there are lots of options here. So I've got like kind of the top Python ones here: Llama Index, LangChain, Semantic Kernel, AutoGen, Light LLM, and Prompty. We just had a session that called Prompty. We're going to have an AutoGen session. We're going to have a LangChain session. Facundo is going to show Llama Index. So, hopefully we'll have more examples to show you, but you are welcome to use any orchestrator that you want. If it makes your life easier, go for it, right? As long as it's compatible with what you want to do, and then it can be a great tool for you. As I was saying, we do have multiple Python solutions that we'll be showing off in the session. So come to the Postgres session to see more Python, and this time with Fast API. Come to the Cosmos session to see more Python with LangChain, actually. So that one will be using LangChain. Come to Facundo's session. He will show Llama Index, but this is even another one that we just put out, another sample with Llama Index that you can check out. And then we just had the Azure AI Studio session with Prompty. So here you go. If you want to start ragging in Python, you could start with the solution I just showed and with deploying that using that free guide, or you can start from scratch or start from any of our other samples, start from tutorials, start somewhere. That's all that matters, right? Just start somewhere and see what happens, right? I've got office hours tomorrow at noon PT. If you want to come in and screen share or ask questions, come along to the office hours. They'll be in the Discord. And if you have any questions, you can post in the issue trackers for the repos or in the RagHack discussions themselves. And please come to the upcoming strings. There's going to be a bunch that are using Python and even more than that. So there's going to be a lot of Python love during our streams. So thank you, everyone. I am overtime now. We'll try to share everything there. But any questions that we didn't make, just go ahead and post it in the discussion thread for this session. So you can find the discussion threads just from this table here. And so any follow-up questions, stick them here. I'll be subscribed to the thread and I'll answer all the questions. All right. Thank you, everyone. And thank you, Sarah.
Yeah, thanks, everybody. The link to the Discord for those events and stuff is in the chat, too. So make sure to join.
All right. Thank you both for an excellent session. We love feedback. We always appreciate what you have to say. So our link for our survey is on the screen. We've also posted in the chat, and this event code is 23335. Thanks, and we will see you on the next episode.
Hey, everyone. Hope you enjoyed today's session.
If you aren't registered yet for RagHack, you can register now at aka.ms/raghack/register, and you can introduce yourself on our forum. You can start hacking either by looking at one of our code samples or just starting from scratch. If you have any questions along the way, feel free to post them in our GitHub discussion forum, and you can also attend live office hours in our Discord. Once your project is ready, make sure to submit it before September 16th at 11:59 p.m. PT to be eligible for our cash prizes. And of course, make sure to join our upcoming live streams to learn more about RAG. Thanks for joining.